right, I picked some problems off of Big Ideas. They're not in your homework, but they're ones that we can use as sample problems to show you guys, hopefully, how to figure this stuff out. So let's take a look here at problem number 1. Identify the graph of g of x equals 3 tangent x. So this can be just your basic tangent x graph, except that it has an a value of 3. So you have to understand how to make that. You know that that's a vertical stretch, but how do I see that in a graph form? I'm going to show you. So first off, I glance at these 4 graphs down here, and immediately I can mark off these bottom 2 graphs. Now, why can I do that? Remember that the tangent function increases. From left to right, it goes upward. What are these 2 down here? These 2 are the graph of a negative tangent function. So process of elimination, those 2 are out. All right, so now I look at these 2 here, and I go, okay, they both are going in the correct direction. Now how do I determine which one? Well, I need one with a vertical stretch of 3. What does that mean? In a graph form, here is what you're looking for. Go look at what your period, or I want to see your asymptotes. The asymptotes are always at either end of your period, right? Where you see one complete cycle. All right, so those are the asymptotes here for this graph. Now, what if I look at the interval length? So I would split that in half and then half again. And why is that important? Because that's where we look for our key points. All right, in graphing, we always use key points, and we need to continue using key points even with these trig functions. So look at my key points. It passes through 0, 0. Now, if I go over 1, meaning 1 interval length, how far up does my graph go? Well, it looks to me like it lands about there at about 3. If I go back to 0, 0 and I go left 1 interval length, I end up down here at about -3. Do you see that? So if the distance from my center line, this is kind of my center line, I didn't have a shift up or down, so that's my center line. And what is that distance right there? Can you see that distance that I, from that key point, whoops, ignore that. From the key point down to here, that's a distance of 3. And what is down here? A distance of 3. That's what I want. That's what that a value does. It stretches it, meaning normally those key points go over 1, up 1. This one instead goes over 1, up 3. So just to show you that yes, this one is the winner, but why is this other graph not? Well, go look at its key points. Once again, if I look at those asymptotes, so let's take a look. The asymptote is going to be here at pi halves and negative pi halves. And go look at the key points. It goes through 0, 0, and then it goes, what, over 1 and up like a fourth, right? Or a third or something. It's some little fraction goes left and down. So that is not the right a value. All right, so just to make sure you get this, we are going to actually practice graphing. What if I told you, hey guys, rather than picking the correct graph, I want you to graph this by hand. All right, remember this is in the form a tangent b x minus c plus d. It's the same formula for every trig function. You just swap out tangent for sine, for cosine, whatever you want. Okay, in this case, a is 3. My b is 1. Now, why is b important? Because that is going to then give me my t, my period. And for tangent, period is always pi divided by b. That's an important thing. Tangent, cotangent, normally have a period of pi. Secant, cosecant, sine, cosine, all 4 of those will always be the period is 2 pi over b. All right, so if b is 1, that means pi divided by 1, or my period is pi. All right, my c value is 0. That's my left and right shift, which I do not have a horizontal shift. D is 0. That means I do not have a vertical shift. All right, tangent is the only one that's centered on the y-axis. That means if my period is pi, I want it centered, so I'm only going to go out pi halves because I'm going to go out pi halves in either direction for a total distance of pi. That means when I go to graph this, I'm going to have an asymptote on either end. Now, had I had a horizontal shift, I would have done that before drawing in my asymptotes. Okay, the next thing is I need to get those interval lengths so I can do my key points. So I do it in half and half again. And where are those values? That is going to be where? At pi fourths and at negative pi fourths. All right, now I take a look at my A. From my center line, I didn't have a shift up or down, so that means starting at 0, I'm going to go up 3 and down 3. Those are important for where my key points are. So my key points are at 0, 0 right here, and I go over 1 and up 3, so I'm right there, and I go left 1 and down 3, and now at this point, all I have to do is what? I just have to connect these, right? And that gets me the graph of 3 tangent x. All right, you guys got this. Let's try another one. Oh, blank page. Here we go. Identify the graph of g of x equals 3 cotangent 1/4 x. Okay, once again, there's my A, so A is 3, right? So looking at those key points, I'm going to want to go up 3 and down 3. What's that 1/4? My B is 1/4. Okay, that affects my period. My period, remember for cotangent, is pi divided by b. So what happens if I take pi and I divide it by 1/4? What am I going to get? Do copy dot flip, and I get 4 pi. So taking a look at these, I'm going to start out looking at the period. Which one of these graphs has a period of 4 pi? So let's go take a look at the first one. Now notice this first graph is kind of hard to see, but can you tell if I follow it along? Let me get a color here that I like. If I follow this graph, take a look. From right here to here, and then coming up from here to this point. That is one complete cycle right there, you guys. That means if I'm looking at the period, the cycle goes from negative 2 pi to 2 pi. That means this particular has a graph that has a period of 4 pi. Now, if you don't like looking at it that way, if that's kind of hard for you to tell, then just extend your graph, you guys. Take a look at this. What if I just followed it? Where is that heading? It's heading down this way. And exactly how far is it going to go out that way? Well, it's going to go until I hit 4 pi, and that's where the asymptote will be, is at 4 pi. So can you see that? How do I know that for sure? We'll take a look. Half the graph took 2 pi to go, so go another 2 pi, and I know it's out to 4 pi. All right, so that has a good period. I like that period. We want to keep that graph as a possibility. Look at this top right one. It has the exact same thing from what? Negative 2 pi to 2 pi. It also has a period of 4 pi. It's good. Bottom left, what's its period? For one complete cycle, it's got a period of what? Pi. All right, automatically, he's out of the running. All right, what about this bottom right one? One full cycle takes how long? 2 pi. So this one is saying it has a period of 2 pi. Nope, I want one that has a period of 4 pi. He's out. All right, so my options are these top two. Now, how can I tell which one the correct one is? Well, we've already checked for the period, and the period matches, so what do I need to look at? I need to look at that A value and see which one has the right A value. So take a look at this one. If I were to do one cycle, and sorry. I need my cycle so I can see one complete curve. So we're going to look at the cycle right here. If I split in half, and then half again, that's where my key point should be. My key point should be where? At 0, 0. Then if I go left one, I should be up, what was my A? I should be up 3. Whoops, a little higher than that. 3 is about right there. If I go right one interval length, I should be down at negative 3. Does my graph match up with those? No, it doesn't. So, what do I know? Again, process of elimination, that one's out. Let's prove that this one is correct. Now, in order to do that, I'm going to erase some of this to make sure you can see what's going on here. Okay, once again, I need to see one complete curvature, one section of this graph. So I'm going to extend this out, knowing that what? It's going out here with an asymptote at 4 pi, right? Okay, so if I do those interval lengths, let's take a look. I go from here to here is my asymptotes. Halfway is 2 pi, and then split that in half, at either spot. That's a little too far out, a little closer. Okay, let's check my key points. 0, 0, yep. Left one interval length and up. Where am I at? 3, boom, that looks good. One interval length and down. 3, that looks good. He's the winner. Okay, keep going. Now we're going to practice graphing it. What if I didn't give you multiple choice and I said, go graph this? How do we do it? We go straight down. A is 3. B is 1/4. How does that help me? It gives me the period, which is pi divided by 1/4, which is 4 pi. Okay, C is 0. That's my left and right, so I don't have a horizontal shift. D is 0. There's no vertical shift. Okay, for cotangent, I am not going to center it on the y-axis. It actually just goes from 0 out. So from 0 to 4 pi, I'm going to automatically split that in half and half again so I can get those interval lengths. I need them to be able to see my key points. All right, I'm going to put in some asymptotes here. So I would have an asymptote here at 0, an asymptote here at 4 pi. Now I know that my A is 3. That means from my middle line, I'm going to go up 3 and down 3. And do you understand when I say middle line? This doesn't really have amplitude because amplitude is based off of a maximum and minimum. So we just kind of call it my center line. And how do I know where my center line is? This D value. Okay, that's where that center line is going to be. So starting at 0, I want to go up and down 3. Okay, I put in my key points. Okay, right in the center is going to go on my middle line at 0. Over one interval length, whoops, I go up, or sorry, down 3. No, I was right. It is up 3. Why? This is cotangent. Cotangent decreases. Tangent increases. They're just the flip-flop of each other. Over one interval length and down 3. And that, my dears, is the graph of cotangent. 3 cotangent 1/4 x. All right, hang in there. I got one more problem for you. Let's take a look at this one. Use the graph to write a function in the form y equals a tangent bx. All right, so what do you need to know? You need to know your a value. You need to know your b value, your c, and your d. And once you have that, what do? You go plug into the function y equals a tangent b x minus c plus d. Once you have all the letters, it's a matter of plugging it in. All right, to find a, remember what's a? A is that vertical stretch. How do I figure that out? Well, here are my asymptotes on either side. I cut that in half and then half again, and go take a look at where my key points are. I'm at 0, 0, and then where? Over 1 and up 6. Notice how this is counting. That's at 6, and I go left 1 and down 6. So what does that make my a value? You got it, 6. All right. Now, what was my period? If I were to list what my period is, my period on this graph, it goes from what? Negative 1/2 to positive 1/2, which is a total, or sorry, pi halves. From negative pi halves to positive pi halves, that is a total of pi. And I know my period for tangent is pi divided by b. Well, what would I put in for b? So when I divide pi divided by that number, I get pi. You're right, the answer is 1. You can use logic, or if you want to solve this equation, pi equals pi over b, you can solve it, multiply both sides by b, and that gives me b times pi equals, I'm trying, you guys hear this, hard to write with, equals pi, divide by pi, you get the picture here, and I'm going to end up with pi divided by pi, which is 1. Okay, so if you want to do some algebra, you can. All right, C value, that is my shifting left to right. Well, notice my key point went through 0, 0, so I did not have a shift. My D value, that's up and down, right? My vertical shift, I went through 0, 0 again, so that is 0. So now what do? I come over here and I plug it in. Y equals 6 tangent 1 x minus 0 plus 0, but I would never leave it like that. I would simplify into y equals 6 tangent x, and that is my answer. Okay, you guys, I hope this helps you with your homework. Good luck, and email me, be in contact if you've got any questions.